All right, good evening, everyone. You're welcome to software development class, and it's good to have you guys again. I hope your week is off to a great start. If you can hear me, do let me know in the chat section. All right, if you can hear me, just notify me in the chat section. All right, great. We are welcome to class 7 of the software development course with Digital SKILLUP Africa. This is the week 3, and I hope the journey has been of great benefit so far. All right, great. So before we start tonight's class, before we start today's class, I would like to do a quick recap of what we've learned so far, especially what we learned last week. And as usual, if you have any question, feel free to drop it in the comment in the chat section. All right, great. And also feel free to drop where you're joining from. All right. So as a quick announcement and also to update us with a bit of information, we started our first assessment last Friday. I hope you guys saw the link for that. And as of the time I last checked, I think about 170 people already submitted their responses. And on an average, we have a score of 22 out of 30, which I think is a very good number. And we have a good number of you scored 30 over 30, which is also great. And I do want to appreciate the ones that have submitted their responses so far. But you do have up to Friday to respond to the assessment, after which you won't be able to attend to it again. And on Friday, you will have fresh assessment. Also, I want to make mention that going forward, since we've started coding, we'll be making the source code available for you. I know it's kind of hard to follow as the instructors are doing the live coding session, so we have gone ahead to write the code that we'll be using in the classes, and after each class we will try and make them available to you. For now, we'll just provide you a download link for you to be able to download the source code, but in subsequent classes, after we've done Git and we've introduced you to GitHub, you'll be pulling your code from GitHub. But for now, we'll make the code downloadable. All right. Okay, great. So today we'll be looking at an introduction to backend development, and we will look at APIs as well. So after today's class, I'll be providing you with source code for the backend API that we are going to build in this class, and also there is another project which is a very basic project, but we have that extra project for you guys also to be able to sort of have better understanding of how we've come so far. So we have an age calculator code which you can play with as well. And the essence of giving you this code again is for you to be able to follow along. We know that we may not be able to carry everyone along during the live classes, but we also want everyone to benefit from whatever it is that is being done during the live classes. So codes will be available for you. Do look out for when the link will be made available. So you will see it on the screen towards the end of the class, and there's also a QR code for you to scan to be able to access where the source code is. So last week we spoke about programming languages. We did introduce you to what syntax is, variables, functions, and the like. We talked about control flow. And in the second class, we did introduce you to integrated development environment, which is IDE, which is like a software for you to be able to write your code on. And on Saturday, you were exposed to TypeScript, and your instructor did talk about some basics of TypeScript. So far, I do hope by now you'll be able to define what a variable is, or be able to talk about functions, or write loops, or what conditional statements are. And hopefully you are also able to write simple programs that are using all these constructs already. And we are hoping that you have gone ahead to start practicing. And like we mentioned during one of those classes, that we're exposing you to the basics of programming languages so that you can go back and also experiment. So the more time you give to these things, the better you get at it. So we started out with TypeScript, but you are not limited to TypeScript. You can go ahead and start practicing with Python if you like. The basics applies to Python as well. And also last week we introduced you to VS Code as part of setting up your developmental environment. Yes, we also made mention that there are other IDEs aside VS Code, but we started out with VS Code so that everyone can be on the same page. And given what we intend to cover in this course, VS Code seems appropriate for what we have in mind to teach you in the next 3 months. All right, we also feel that by now, with what you've learned so far, you should be able to navigate the IDE you've chosen, and also have a good understanding of debugging with your IDE. And from Saturday's class, we also are hoping that by now you already are familiar with what types are in TypeScript, and why we even need something like TypeScript to start with, and that you're able to compare TypeScript with JavaScript and other languages as well. And we also talked about the process of transpilation last week. So by now you should also be able to compile or transpile a basic TypeScript code. All right, so this week we'll start with backend basics, and I'll be introducing you, like I mentioned earlier, to what APIs are, and what backend programming really entails. So we'll talk a bit of theory today. I will try and spend the first hour talking about some theory, and then the second hour we'll do some live coding session to really show you what we mean by backend programming and what it means to build an API. And like I also mentioned earlier, that all of these codes will be made available to you at the end of the class, so that you can go back and test by yourself and play with the code by yourself. And if you can, also extend whatever it is that we are going to write today. All right. So in today's class, we are going to cover a bit, and I might be faster than usual, just for us to have ample time to focus on writing code. But don't worry, you can always go back to this class. You can always watch the video again and again. So don't mind the speed. But regardless of the speed, if you have any question, do drop them. When the time is right, I will attend to them. So you're welcome to class 7. This is the 3rd week. And in class 7, we will talk about introduction to backend programming. My name once again is Deji Abimbola, and I'm one of the facilitators for DSA software development course. Okay, so what are we going to cover today? In today's class, we will look at software architecture. Yes, we introduce you to what software architecture is, but we do have a dedicated class to really go in depth on that. But I feel like we need an introduction to this so that we can gain better context of what we'll be talking about in today's class. So we'll look at client-server architecture being the basis for software design. In that part, I will explain to you how to visualize software architecture from the point of view of a client and a server, a client making requests and a server serving up response to those requests. And then we'll look at HTTP and the various versions of HTTP. We'll look at HTTP verbs, and then we'll consider what a resource is. And in the context of HTTP communication, we'll look at what a resource would mean. Then we'll go into our coding session. And then in that coding session, our focus will be around REST. Well, just follow along with me. You will understand what REST means and how it fits into the entire picture of writing backend code. And then lastly, we'll look at beyond APIs. We'll look at what security consideration we should have in mind and other communication protocols. Again, as we go into the class, you will gain better understanding of all of this. So at the end of this class, we are hoping that you will gain an understanding of the role of backend in a full stack application, or the role of having a backend in your software. So we'll be defining what APIs are and how they enable communication, and also you should be able to recognize the request response cycle in a client-server model. All right, so I will look at our interaction on the chat now to see if there are anything that I need to pay attention to. So someone is asking about the assessment link. Okay, I will try and make that available as well at the end of this class, so watch out for that. Or as a matter of fact, you can go back to the last class, which was the one on Saturday. Towards the tail end of the class, the link was shared. So I want you to go back to that class and get the link from the very last class, which was on Saturday. All right. Okay, great. So, software architecture. So let us start with a brief introduction of what software architecture is, and we shouldn't confuse this with software development methodologies, which we dealt with, I think, in the first week of this course. So software architecture is quite different from development methodologies. Software development methodologies talks about how you go about building your software, going from design to develop and to deployment and all. But when it comes to software architecture, it actually talks about how you write code, how you make decisions around how your code interacts, and how you make decisions around how your system that you're building sort of talks one with another. So software architecture is the high-level structure of a software system. So now we're talking about the structure, not just how you go about building it, but the structure that your software will have. So software architecture is the high-level structure of a software system. Essentially, it's the blueprint. So when you're building a house, for instance, you do an architectural design of the house, right? And in your architectural design, you probably have a placement for your sewage system, how you're going to run plumbing in the house, where the kitchen would be, where your bathroom would be, and how you're going to place your doors and all of those. So if you begin to look at software from that perspective of placing things or having a design for how an entire system will turn out to be, then you begin to understand that when we talk about software architecture, we are also talking about the structure of a software. So it defines the system's major components. So for example, you can have modules. Modules can sometimes be focused on, say, user authentication or fetching user transactions. I mean, depending on the system you're building. And then it also focuses on the relationship between these systems. So you can have a system that allows a user to sign up and then a creation module or services, and then the email services is also part of the architecture of your software. And then we also have, as part of software architecture, some principles guiding the design and then the evolution of your software. So depending on the architecture that you have, it might impact how the software evolves. If you choose wrongly, then your software might have a difficult time evolving with new requirements. As you may be familiar with, or if you are not aware of it, software changes, software evolve. A good example is taking WhatsApp, for instance. You get frequent updates on WhatsApp. That's software evolving. So imagine if the architecture was not done properly. It might be difficult to actually add new features to WhatsApp in this case. Same thing with building a house. If the foundation is not solid, even though the architectural design stated that you are building a two-story building, but you now have a weak foundation, that already limits how far you can build that house because due to that weak foundation, there's so much weight you can put on the foundation. At most, you probably can only go one floor above ground. So that also applies to software. The type of architecture or how well your architecture is done determines how well your software also evolves. So like I mentioned, it's like a blueprint for building your software. So it defines where the room width will be. Now rooms in this situation would mean components in your software. So how the rooms will be laid out, where the sitting room will be, where the bedroom will be, where the windows of the bedroom will be facing, because all of those are essential in building your house. So for instance, you don't want your window to be facing where the sun sets, because if the sun sets where your bedroom is, which means your room will be hot in the evening and all of that. So all of those are decisions that we take when building a house, and same thing applies to building software. You have to make decisions, and those decisions informs how you architect the software. So we have quite a few types of architecture when it comes to software design, and each of these outlines the building block of a system and how they interact and communicate. So essentially, we are saying that the architecture of your software determines how individual components that makes up the system or that makes up your software get to interact and how they communicate. I remember I mentioned earlier that we'll be looking at HTTP. I would like to mention it now that HTTP is actually a communication protocol for software systems. So when we come back to HTTP, I wouldn't want you to be wondering what HTTP has to do with software architecture and all of that. So let's look at the different types that we have. Again, I'm trying to rush through this so that we can have ample time to do a live coding session. During that live coding session, I will try and be slow as possible so that you can follow along as much as possible. So types of software architecture, we have a monolithic architecture. I'm going to explain all of this, but let me just run through them. We have layered n-tier architecture, we have microservices architecture, we have event-driven architecture, we have serverless architecture. And as your career progresses as a software developer, you become more and more exposed to this different architecture that we have for software. As you're starting, you may be exposed to monolithic or layered architecture, but as you progress, or as the system you're building become more and more complex, and as the need arises, you may now start dealing with microservices and event-driven architecture and the likes. So when we say a monolithic architecture, what do we really mean? What do we really mean? So a monolithic application is built as a single unified unit, and all features, components. So when we say features now, in this case, we are talking about the UI. And what do we mean by UI? The user interface. So the part where your user gets to interact with, that is a component in the system. So that component is bundled together with the business logic and bundled together with probably your database as well. So how you access your database is all built together into one system. And some people also refer to monolithic. Well, again, as your career progresses, you'll come across these things, but we just want to expose you to them as early as possible. Some people also talk about monolithic in the sense of how codes are co-located. So some people say a software is monolithic because the code for the backend, the code for the front end, how you access your database are all living together in one project. But beyond that, a monolithic architecture has all components living in a single code base, and how they interact also shows that they are one single unit. So it's not like you are calling an external service. Everything that you're doing is one and the same. I've worked on a project before where the code base is actually together in one place, but communication between the UI and the backend was done via APIs. I will explain what APIs are, but it does happen that your code base is co-located. Doesn't necessarily mean that it's a monolithic architecture. But again, as your career progresses, you will get to understand these things. All right. So I'm going to take a look at the chart in case there are anything that would require my attention. Okay. All right. So, for example, when you build a blog site, for those of you that are maybe using WordPress already, or you are building a company website, that's a monolith, because everything that makes the website work is all living in the same code base, is all living in the same system. There's hardly no communication with an external system. So in practice, monoliths are very convenient for small projects. So in case you want to build your portfolio, you don't need to necessarily break it into APIs or have a separate front end. You can have everything residing in the same project and all communication within and performing as a single unit. All right, so let's talk about layered architecture. In layered architecture or n-tiered, and when we say n-tiered, we are talking about the different levels that is contained in the layer. So you can have a 2-layered architecture, you can have a 3-layered architecture. That's why you have the n-tiered. So it's depending on how big your system is. So in this type of architecture, the system is divided into stacked layers. So I mentioned earlier in monolith that you have your UI, your business logic, how data is accessed all in one project or all as a single unit. But for a layered architecture, they are existing as different entities, separated based on their function, based on what each one is meant to focus on. So we call it a separation of concerns, right? So in a typical layered design, you may have the presentation layer, which is like your UI. I mean, I've worked on projects where the UI is a separate project, and then you have a backend, which is a separate project, and the communication happens via REST or via an API. So such architecture does exist. All right, so components in one layer only interact with the layer above or below, right? For example, an online store might have a UI showing products, and that will be our presentation layer, right? So it's showing products and then a service processing orders. So when you land on the page, you click to buy a product. All of that interaction is sent to another layer, which does the processing of the product that you actually want to buy. And then you have a data layer that keeps a store of the inventory of the products you have on your platform. So in such a way that when I order a product, the service layer processing the order, we send like a transaction down to the database that we now tell the database that, okay, this item has been bought, we should reduce the stock that we now have. So if there were 20 items before, on making my order or making my purchase, it should no longer be 20, it should now be 19, and so on and so forth. So let's talk about microservice architecture. And again, I'm trying to rush through all of this because we have a dedicated class for this. So I'll just give definition of this different architecture, and then we proceed forth to talking about client-server architecture, which is like the basis for every architecture that you get to meet. So talking about microservices architecture, so this type of architecture decomposes the application into small independent services. Now we are not just talking about the UI and the business logic or the database. We are talking about specific independent service using the online or e-commerce website example that I gave earlier. You can have a service that processes order. You can have a service that sends out email. You can have another service that keeps track of your shipments. So all of these are independent services, but they interact one way or the other. And how they interact is dependent also on the architecture. There are different communication protocol, which we'll get to in another section. But just know that in microservice architecture, they are independent small services all interacting together. So talking about event-driven architecture, which is also, or which microservices can learn from, but it's not always about microservice alone. So in an event-driven architecture, components communicate by emitting and reacting to events. You know, I was mentioning about communication, how different entities in an architecture communicates. For event-driven, an event. So when you click an order on an e-commerce website, that new order is seen as an event, right? And that triggers a lot of things in the system because you have made an order now. The stockpile is updated, reduced. Email is sent to you as the purchaser. An email is also sent to the seller as well, that, oh, you have a new order from so and so, and you get an email that your order has been processed. And email is also sent out to the warehouse that an order has been created to so and so address. An email also might be sent out to the person to handle dispatch. So dispatch will go off to the warehouse, pick the item, and then deliver to you. All of these are based on a singular event happen. And like I mentioned when we started the class, it's depending on the complexity of the system that you're building that informs the type of architecture that you reach out for. If you're building something as simple as your portfolio website, then having a monolith is sufficient. You don't need to be sending event out or be listening for an event to react to an event. All of that is an overkill for a simple portfolio website. And again, as your career progresses, you will come across all of this. And the last one here is serverless architecture. So in serverless architecture, it runs code in the cloud without having a need to manage servers. So you just write a simple code, and then you have a dedicated server that runs that function without you the lifetime of the function for you. Okay, so let's get to the more pressing part of all of this, which is the client server architecture. So when we talk about client server architecture, I want you to begin to see it as the basics of an architecture, because in software development, or in software development generally, you have a client somewhere and you have a server somewhere. So the client is making a request and the server is serving up a response. And in this case, a client can be your computer, a client can be your browser, and a server will be some functions written on a server running somewhere that has database and all of that. But in other situations, for instance, when it comes to microservices, I did mention that microservices are made up of can serve as a client while another is serving as a server, and the same one that is serving as a server right now can also be a client at some other point. The idea is that in a client server architecture, you have a client making a request and you have a server responding to that request, and that is the basis for every architecture that you get to build. There is always a client somewhere and there is a server somewhere. So like I mentioned, a client usually makes a request to a server and the server sends the response back. And by this, we can say the role of what a client is, or the role of a server, is contextual depending on the architecture. If you're reaching out for an event-driven or a microservice architecture, what a client is might be one of your services that you have running somewhere, and what a server is might also be another service running somewhere. And if you have quite a bit of communication protocol before we get too deep into architecture. We should probably talk about this communication protocol, right? And when we say communication protocols, it is how clients communicate with servers. We did mention just now that we have clients and we have server, and one is making a request and the other is responding. But how is this handled? How is the request made, and how is the response sent back? All of this is characterized by communication protocols, or all of this is explained by communication protocols. And each architecture lends to a particular communication protocol. For instance, in a monolithic application, your primary having a REST API or using GraphQL, depending. All right, so the question now is, what is a protocol? I mean, protocol is, as it is, an English language in itself. So it's a set of rules and formats that two or more systems follow to communicate and understand each other, right? The system they follow to communicate and understand each other. So the client that is making a request should be understandable by the server that is receiving that request, and the client that is receiving a response should also be able to understand the response that it is taking back. So you should think about it like a language plus etiquette between devices or software. So imagine you're making a phone call, for instance. The person you're speaking with must be able to speak your language, and then there are basic rules that they are saying before you respond. So this is a protocol. For example, this is a protocol when it comes to conversation, right? Okay, so let's talk about HTTP version. And I do have here some examples of protocols: HTTP, WebSocket, gRPC, MQTT, AMQP. We have SMTP. Some of you might be familiar with SMTP, which is used extensively in email services. So it's a protocol for sending emails. But anyway, we are not dwelling too much on that. Our focus for tonight's class is around HTTP. And I think for the rest of the week, actually, is going to be around HTTP. And then we'll talk about REST APIs. All right, so HTTP versions. Okay, I do have on this some the different architecture where they may apply. Again, when you have the slides, you'll be able to see them, but I can read some of them out for you. In a monolithic application or in a monolithic architecture, we use HTTP, like I mentioned. You can also be using REST or using GraphQL or SOAP. Again, for this class, we'll be focusing on REST. You can find out time to go research on GraphQL or SOAP, or take a bit of time to research what WebSocket is and the likes. All right, so HTTP and its versions. HTTP forms the basis for how websites work, and the full meaning is Hypertext Transfer Protocol. Markup language. Now looking at HTTP, which is Hypertext Transfer Protocol. So it's a transfer protocol for website. And in that case, when you are visiting a website, like I mentioned, and there's always a client and there's always a server. When you are visiting the website, your browser is the client, and where the website is stored is the server. So HTTP is a text-based communication protocol used by clients to interact with servers, mostly on the web. So HTTP has different versions. There's a 1.0, a 1.1, a version 2, and a version 3, and each of them have different abilities and capacities. Some support different communication protocols as well. Like HTTP 1.0 supports and 3. You have more advanced communication protocol that are well suited for different applications that you may come across in today's modern website or web apps or software generally. All right, again, I'm trying to rush so that we can get to the part where we write some code and see all of these things that we are talking about in action. So we have different verbs in HTTP. And what we say when we talk about verbs, right, we are talking about how you, the client, make a request to the server, or how a client make a request to the server, and the different type of requests they can make to a server. So based on the verbs, you can do a GET request to a server, which is telling the server that you want to get something from it. You can do a POST request to the server, which is telling the server that the client wants to post something to it. You can do a PUT request, which is telling the server that it wants to put. And you may be wondering what's the difference between POST and PUT. Well, these are verbs that constitute the communication protocol. Essentially, you are writing to the database, but in the case of PUT, you are making a full update to something that already exists. But there are some other cases too where a PUT can be used to create record if the record don't already exist. And a patch, you are making a partial update to something that already exists in the server. And a delete, by what it means, you are actually deleting something from the server. All right. In all of this interaction, you are getting a resource, you are posting to a server, you are putting to a server. All of this interaction is an interaction with resources that exist on the server. So when you are doing a GET, you are trying to get a resource from the server. So I think it goes to explain what we mean by resource. So a resource is any piece of can be identified or named and interacted with on a server. So in simple terms, a resource is something your app exposes or works with, something like a user. So a user is a resource, or a list of users is a resource. Post is a resource. Product is also a resource. All right. Again, all those verbs helps you with your interaction with the resource that exists on your server. All right, so I'll take a break to look at our question. I know we'll have some question by going by the fact of the speed we are already going with. All right. So I'm going to try and scroll to the very top to see what questions I have for me. All right. So someone is asking for recommendation or materials to read on backend and APIs. All right. We also are pulling together some resources to assist you. I think by the end of this week, we have sufficient resources to also share. So I will try and update that resource to include resource for backend and APIs. All right. Someone is asking about the assessment. Again, you can go to the last class. At the very end of that class was the link shared, so you should be able to get the link from that class. Okay. No, the link was not sent to your email. It was shared in during the class. All right. So let's take a 5 minute break. And during this break, I want to set up my system to be able to share screen with you. So by the time we come back, we will go straight into our coding session. And there is a tool that I also want to share with you that we'll be using going forward, and that may be useful for you as we proceed with the course. So when we come back from the break, I'm going to be sharing my screen. All right, welcome back. So we're talking about the different architecture. Once you can see my screen, do let me know. All right. Um, yeah, I do believe you can see the screen now. And on the screen, I have a tool called upscotch.io. So it's a tool you can use to actually do API requests. And I'm introducing this to you because it will be useful for the class that for the session that we are about to go into. So we are going to build an API. You'll be able to make requests for a quote. It's more or less like a daily quote API that will send you random quotes in the morning, right? And you can also create a quote, or you can delete a quote based on the verbs that we just talked about: the get, the post, the put, the patch, and then the delete. So all of that you can do with the API. And just to be sure that we are not all confused, I did see in the chat section someone was saying that, oh, we went from TypeScript to backend API. Again, the TypeScript that you started learning is a tool, right? And is a tool you can use to do whatever it is that you want to do. So one of the things that we want to use that tool for now is to build a backend. And from my explanation, a backend API or a backend service is sort of like a part of an architecture that you use in building up your software. So if you did choose to have a layered architecture, then you will need a backend, and you need it to communicate with your front end or the different services that you have. So in this case, we have the backend that a UI would communicate with down the line. But before we build a UI for it, this tool that you see on your screen right now will help you interact with the API you are building. So you can see this tool as a client to the backend that you are building. So I'll just do a quick run through of how to use the tool. So right now you can see this, there are different tabs opened up. There are different tabs opened up, and the very first tab, on the very first tab, you see there is a drop down here, and what that drop down helps you do is select the different verbs or how you want to interact with the API. We covered the first 5 in this class, which is the get, post, put, patch, and delete. In later classes, we'll be talking about what to use these other ones for. And then you have like an address bar. On this address bar is where you put the address for your API. All of this you will get to see when we go into the coding session. The address and how the address or how the routing is handled on the back end. You will see all of that. And then you have a send button, right? Clicking on that send button sends a request to the server. Remember I was mentioning request and response. So this send button actually sends a request to the server, and then the server responds with a response. You can see here there's a response body, and in the response body you see an object. The object has the status code of 200. It has a message, quote retrieved successfully, and then it has a data. So the data is this, and contained in that data, if you remember when we were talking about data types, we did mention an array. So this is an array of other objects. So in this array we have 5 objects. If we open up the first one contains an ID, a text, an author, and a list of tags. If you take your mind back to data types, you remember when we talked about different types, string. If you're coming from Python background, or if you have a bit of knowledge in Python, you hear something like dictionary and all of that. So all of those are data types. But again, the focus is not really about the data types. All of that you can learn at your own pace. But it's just for you to see how to actually write these things in real life, right? And how to interact with it pending the time you actually have a UI, or pending the time you build a client for the interaction to happen. So the hopscotch tool serves as a client in this case, and what the client is able to do is make a request to a server and then get the response from the server. So that's it essentially. I know you have a lot of questions, but again, this video is recorded. It's something you can always go back to. And because we have just a lot to cover, when we started the class, we said 3 months is not sufficient to cover everything that you need to know, but we are also committed to ensuring that you actually have sufficient to get a good standing when it comes to software development, hence the speed. All right, so now we are approaching 8 o'clock. Once it's 8 o'clock, you know it's time to take the attendance. So once it's 8 o'clock, we go on a break again to allow you to do your attendance. And by the time we come back, we will actually be coding. By the time you come back, we will switch over to our VS Code, which I believe you all already have set up. But if you don't, you can also go back to the earlier videos that talks about setting up VS Code. And if you are having issues around it, it's something you can easily go online and try to figure out what the issues are. But also, if there are colleagues that you can reach out to that you think can help, yes, you can reach out to them as well. And for those of you that are in the community, in the WhatsApp community, you can also reach out there. We'll be able to attend to it once we get those requests. All right. It's about 8 o'clock. Before it's 8 o'clock, I'll just try and go through the chat again. If there are anything I can speak to. Someone is saying they can't see my screen. Is it that it's too low, or is it that it's too small, or you just can't see it? So the Hopscotch app is a website. You don't need to download it. To access it, you just go to hopscotch.io. It's a website. It's not an app. Okay, the side is too small, so let me try and zoom in. Now I guess it's too big. I hope it's a lot legible now. The live coding session. So your attendance link will be shared in the video description. All right, you guys are welcome back. So while we were away taking our attendance, I took time to go through our questions to see if there are any questions, and I also saw some concerns around the speed. Again, this class, you can go back to rewatch it, but I will try as much as possible to explain the things that needs explanation. So someone was asking if Upscotch is downloaded. No, it is not downloaded. You don't. It's not an app that you download. It's a website that you visit. So if you go to upscotch.io, upscotch.io, you will see this app here. Although you won't see these tabs, these are tabs that I opened up on my own end, but you will see something similar to this when you visit upscotch.io. Someone also mentioned that they already have a Postman. Yes, Postman does the same thing. So the reason why we are using this is for you not to have a need to download something extra. I quite understand that there are a bit of things that you need to download. Some people might find it confusing. So instead of having you download extra software, is why I am using Upscotch. So you don't need to download it. You can just use it from your browser as it is. All right. Another question was about when you will get to see your quiz score. So on Friday, the scores will be released, and you should get the scores in your email. I mean, for those of you that already submitted your response. All right. So I did mention that we are going to go into the coding once we come back from the class, from the attendance marking. And now we have about 50 minutes left, and there's a bit we need to do on the coding aspect. Again, if you're not able to follow along for whatever reason, the code will be made available at the end of today's session. So don't worry. But if you're able to follow along, that also is fine. Follow along as much as you can. All right. So I believe you have your VS Code open. If not, I will give you a bit of time to get that opened. So what we are going to be doing today, we will be creating a project that will highlight all of the things that we talked about in the first hour about writing APIs, and then the HTTP verbs and the likes. All right. So let me give you about a minute, and we'll jump right into it. And I also want to believe that you already have Node installed, and you have NVM working, and you can do npm, you can run npm commands and all. Okay. All right, let's jump right into it. Do let me know if the font is legible. I've tried to zoom in enough to a point that it's still usable, but do let me know. All right. Yeah, someone already responded. It's okay. So in our last class, the facilitator taught us how to create directory and all of those, how to change directory with cd and all of those commands. He was using a Windows system, but I'm on a MacBook today, so those commands will be slightly different. Like he mentioned, that if you're using a Linux system, the commands you have to run will be different. And MacBooks are sort of built on the same kernel that a Linux is built on, which is the pattern themselves around Unix system, so they tend to have the same commands. And as a word of advice, if you're using a Windows system, you should try and install something like Git Bash. Git Bash is spelled as GITBASH, so that you can sort of run the same command that you will typically run on a Linux system, or if you're using a MacBook. And there are also alternatives to that as well. So if you're already using a Windows system and you don't want to install Linux, or you don't want to switch over to Linux, there's a Windows subsystem that allows you to run Linux on a window. So it's called a WSL. You can do a research about that. So that also gives you a terminal that allows you to run command like you would on a Linux system. All right. So what I would do now is create a new project. I'm currently in IO directory. It's all depending on you. For you, your directory might be different. If you're on a Windows, you might want to do this on a desktop, or put it in your document. For me, I want to put it in my document, and I have in my document a folder named developer, right? And here I can now create a folder for DSA. So on a Linux, you create a folder with mkdir. So I'm creating a folder for DSA, mkdir DSA, and then I'm changing directory into DSA. To see what's inside DSA, on Windows you do dir, but on a Linux you do ls, or on MacBook. So right now the folder is empty. So let's create a folder for this API that we want to build. So we'll call it a basic API, and then we change directory into basic API. All right. Since this is going to be a Node.js project, so we are using Node.js and we are using npm and all of that. And let me confirm what Node version I currently have. I believe we learned that in the class that we installed our IDE and installed Node. So right now I'm using Node version 18.18. I can stick with this, or I can change my Node version to use version 20, like we were taught in the class last week. But I can also stick with version 18, which is fine for me, but just to show you that you can also change your Node version as we were taught. So now we have moved to Node version 20. So the Node version 18 or 20 really doesn't impact what we are doing. I'm just doing this as a form of recap for what we learned before. All right, so for this project, we are going to initialize a new project with npm init. I'm not sure we were shown this, but this is a way you can start a new project or a new Node project. So now it's asking me, what do I want to name the project or the package? So it already picked the name I gave the folder, which is basic API, and it's asking me for a version. All of that is fine. It's asking me for an entry point. We update this to be dist/index.js, and I will explain why I'm making it dist/index.js. You know, in the last class about TypeScript, we talked about transpilation, right? So what I'm doing here is I'm saying that I want transpilation to go into my dist/index.js. I mean, that would be the entry point, but I will still specify how this transpilation happens, which we called the build process. So when the build happens, it already knows that the transpiled code should go to dist/index.js. Right now, I've not set a GitHub repository, so I'll just skip through this. These are not necessary, but if you want to. So now it's showing us what we have so far. So all of this that is showing will go into package.json file. Package.json file. So it's asking if everything is okay. Yes. All right. So I'm going to show you the file. All right, so we already did this, but we have not opened the project yet. So let's open this project that we started. So I'm going to click on open folder. And it's in my developer DSA basic API. And we open this. All right. Let me close the. Okay. All right, this is good. So now we have our package.json that is created for us. So package.json holds some information about the project that we are working on, such as the name and then the entry point to the project and what have you. All right, so what we will do next now, having had this package.json, we will try and create some folders, and the folders we hold some of the codes that we want to write for the project. So the first one that I will be creating is source src, which will contain all the source code for the project. And then I will also create another one. For quotes. You know, I said we are building an API that will show random quotes, or when you specify an ID, it will show you the ID, the quotes that has that ID. All right, so we have source now, and then the next thing to create is another folder. So we click on new folder, and then let's call it quotes. Inside it, we create a file that contains all our quotes. Please ignore all this that is showing up. It shouldn't show up for you. So this API is going to be reading from file. What does that mean? We have our data written in a file as part of the code. So let's call that data quotes. So it's going to contain quotes. I mean, just follow along. The essence is to see how we write backend codes and how to actually inspect it using the tool OSPOTch, and then to solidify our knowledge of HTTP verbs. So there are some things that I will do that you may not understand now. Again, I'll provide the code that contains all the implementation for this class, but just follow along. I'll make highlights on the parts that are really important for you for this class as we go along. So now there's going to be a quotes file, quotes.json file. JSON is a file extension for JSON files. And a JSON file can hold objects, can hold array of objects, and so on and so forth. Then that's taking us back to our data types class. All right, so for this JSON file, it's going to be an array, and an array in JavaScript or TypeScript is denoted by square brackets. So an array contains elements, like a list of items. So here we are saying that we have a list, right? And the first item there is going to be an object. Okay, Copilot is trying to do autocomplete for me, but I don't need that. So we have the first item, which is ID of 1. And yeah, let's make it a string. ID of 1. And then we have text. Okay. Let's go with that. And we have the author, which is Franklin D. Roosevelt. All right. Then we need a comma here. So there's an author. We also want to give it a tag. And what a tag is we are going to use it to describe what kind of quote it is. So for this one, we can tag it inspirational. Yeah, so inspiration. This needs a comma at the end. Yeah, so this can be our list of quotes. Let's add one more so that we indeed have a list. Okay, Copilot is already completing it for me, which is good. All right, I'll just go with it. It's okay. So this is our list of quotes. Let me zoom out, or okay, let me do this so that you can see everything in it. All right, so we have a list of quotes. The very first one there has an ID of 1, the second one has an ID of 2, and so on and so forth till we get to the fifth one that has an ID of 5. All right, now in the database class, you'll be taught an alternative to this. So instead of reading from file, which doesn't scale, I mean, imagine you have 100,000 people trying to read the same file. That creates an issue. But it's better to deal with databases for cases like this. But since we've not already taught database, so we will leave that till Friday when you're taught database. But for now, let's read from file. So we already have our quotes file. Now what we will do next is, how do we read this file, and how do we prepare our backend to be able to receive requests and give a response back? So in our source file, in our source folder, there are several things that we need to do. First, let's create a file handler, and what this file handler is going to be doing is as follows. It's going to get the path to the file, and by path I mean it's going to give the location of where the file is. You know, we named it quotes and quotes.json, so the file path will essentially be like quotes/quotes.json. Right, so in the file handler that we are going to write, we want to be able to get the file path. We also want to be able to read quotes, right? And maybe able to write quotes as well to file. We also want to be able to get quotes by ID, add a new quote, update an existing quote. But because of time, we won't implement all of this. But there's a code that has already been written that contains all of this that you can go ahead and look at the end of the class. So let's just focus on two functions. Remember when we talked about functions that, okay, functions deal on specific functionality. So I mentioned we need to get the file path and read quotes, and I think get quotes by ID is also good. But for time, we'll just implement two. So in our source folder, we create another file called file handler. So file handler.ts. All right. And in it, we have a function called get file path. I mean, you can name it anything, but I'm trying to be descriptive as possible. So this function, we accept the parameter. Again, this class is not about teaching function, but I'm spelling all of this out in case someone needs the extra information. So it's going to accept a string, and the default file path that we have is going to be from quotes.json that we earlier wrote. All right. Let me make this visible for you. Okay. Okay, so what we want here is this function should return the path to the quotes.json. So we're going to be importing a module that is part of Node.js, right, which is in path. It's called path, and this is going to join the current this is how you do an import in Node.js. So we are importing all as path from path. It's going to give that squiggly line because we don't have path installed already. But never mind, we'll get to the part where we install all of these modules. But for now, what we want to return is the full path to quotes.json. So that's going to return path.join. So get the current working directory from process.cwd. cwd current working directory, which is a function also, and quotes. Again, just to reiterate, this code will be made available to you to play with at the end of the class. So in case you feel like you're not really following, I will give you the full code at the end of the class. But what this is doing is going to return the file path, which we will need, and then a second function that will read the quote from path. So let's In the last class, we were meant to talk about error handling, but I'm not sure we got to it. So in case you're wondering, what is a try catch for? A try catch is to actually handle error. So one of the errors that can come up when reading from file is that the file doesn't exist. So you want to be able to cater to that. And how you do that is you wrap your code in a try catch. So inside the try block, which is from here to here, is where you want to write your code. And in case that code fails, this catch portion will run. And the catch portion, we just want to write to console what the error is. So error reading codes file, yeah. But in the try portion, we want to read the file and put it in a const data equals okay, so for us to read from file, we also need to import the package that actually allows you to read from file. So we are importing fs from node modules. All right, so now we are able to do fs dot read file sync. Each of these parts, you can actually read them up individually. So something like this read file sync, it will have a documentation that talks about what it actually does, because there are many modules and there are many libraries that you can use in building software that we can't actually exhaust all of them, but there are some standardized and for particular usage. One of which is this FS for reading file. So FS stands for file system. So the package allows you to interact with your file system. All right. So now what we are saying is it should read from file synchronously. And this function expects to get a file path. And we know we are doing our file path. We are getting our file path from this function up here, get file path. And then we say it's expecting it to have an encoding of UTF-8. Encoding is something else you can also read up on your own. I think it's currently beyond the scope of this class. I mean, this course entirely in itself. Because again, the 3 months we have won't allow us to deal with everything that has to do with software development. But again, if you can apply yourself to actually doing research, so if there is anything that you find confusing, you can actually do a read up on it. All right, so we want to return the data that we got from reading the file. We are going to return it as a JSON data. Also, JSON is something you can read up on, but JSON is an object type in JavaScript. I mean, it's common with JavaScript and other programming languages also, but it's a way to return data or pass data around. When it comes to client or server, you can return a JSON object, for instance. And even while we are building our API, the communication between the client and the server will be based on JSON. So the data that is being exchanged between those will be JSON. So JSON is quite popular, right? So what we are doing here is we are converting what we are reading from file into JSON object, which JSON.parse is doing. So as it is now, we are able to read from our file. One other thing that I want us to implement is to type this response we talked about types in our TypeScript class. I mean, the reason why we even did TypeScript at all is because of the benefit of what type can offer us. So we'll go back to our source folder, and we're going to create a types file. In this types file, we create a type for quotes, right? So let's create a type for quote, export, interface. So this is how you create a type, a custom type in TypeScript. We know we have an ID, and our ID, we want it to be a string, and the quote is a string. Oh, no, we are actually using text, so let's use text, not quote. Text is a string. Then we have an author, that is also a string, and then we have tags, that is an array of string, and that's that for quotes. All right, so now we can import this in our file handler file. So we are importing quotes. You can see that it's actually auto imported it at the top there. So it's going to be an array of quotes. All right. Okay, it's complaining because we don't actually have a return here. So let's return an empty array if an error occurs. All right. And get expect 2 argument but got 0. Okay. Okay, there's a mistake here. This should be an equal to set it to default. All right, so before we proceed, let's install our node modules, and we do that by doing npm install, npm I or npm install, and this installs node modules for us, which contains some default packages that typically comes with Node. If you have some extra packages that you want to work with, you can also specify them. But for now, all we have is just vanilla Node, right? And then TypeScript. So because we are also using TypeScript, we will need to install TypeScript, and then because we want to be able to run our TypeScript code, we also need to install types. I mean, for us to be able to type the code, to get the right typing for the code we are writing, we also need to install types. So we need 2 packages now to install. We need TypeScript and then type/node. So let's do TypeScript installation first. npm install. You notice that I put a D flag. We are doing that so that TypeScript is just installed as a dev dependency. It's not needed for us to run the code eventually. It's just to help us in the process of developing. All right, so we need to wait a bit for that to happen, and that is done now. So we've installed TypeScript. If you go to your package.json, you should see TypeScript already installed as a dependency, as a dev dependency package. So the next one that we need to install is node types, and that you can do by also running the installation command that we earlier used for TypeScript. So at types/node is what we need to install, and we press enter. All right, so you see that the two packages have been installed now. So let's go back to our file handler, and you see that those errors that we were earlier seeing now resolved as well. Okay, so we have two functions. Let me close this so that you can see the codes properly. We have two functions, read quotes and get file path. Now, when it comes to serving up response and receiving requests, we need to write some code for our server. All right, so this would mean that we need another file that will be able to write the codes that are needed to send response or receive request. All right, so we need to go a little bit faster so that we can really cover the essential part that I really want us to cover for this class. So we create a new file, server.ts, a new file, server.ts, and in that file we want to create some set of functions, send response, and then another one that will pass response. So these are functions that we are writing ourselves, and then we will write one extra function that we get all quotes. I will implement them. I'm just writing out the functions that we need for our server. So handle get all quotes. By the way, I know some of you might be concerned that we are too fast. Again, this week is dedicated to backend programming. So all of this that you're seeing, you'll still see them again. Even if you are not following well, your class tomorrow will still come back to touch on some of these things. So don't be too much concerned. And like I mentioned, all of the code will be provided to you. We are going this fast so that at least in the next 3 months, you will have been able to actually acquire enough. Again, software development is not something you learn in 3 months, but we want to try and expose you as much as possible to all that you will need. For some of you, you don't even do TypeScript already. But as we are saying these things, by the time you come around to actually learning a programming language, at least you can cast your mind back to some of these things that you learned, and it will begin to make much more sense to you. So do bear with us, even though we might be going too fast. Again, these videos are recorded. You can go back to them after the class. So we have three functions that we want to implement. The first one is a send response. In the send response, we have two parameters, a response and a request and a response. an HTTP server response and then an API response when we are sending a response out. So we have a REST. Again, this is all vanilla Node.js. No package is being installed other than TypeScript. So we need to import HTTP. All right, so we have that imported now. So we want a server response and server response, and we also want a response for API. For our API, so API response, we need to API response is a type that we need to write in our types. So we already have a quote type. Let's include another type, API response. And now API response, we have the following status code. So instead of passing all of that singly into the send response function, we want to pack it together as a type. So we have a status code, which will be a number, and then we have a message, which will be a string, and then we have data, which will be quotes, or let's call it any for now. I mean, for the server we are building, calling it quote is sufficient, but for now let's call it any. And any means that it can be any data type. So we import that. Again, let me make this in such a way we can all see it. All right, so we have the function defined. Now, what does the function do? So it's going to return a void, and in the function itself, we are saying it should write to the response, to the HTTP response that will be sent back. So we have a res.set header. Yeah, that's fine. Set header, that's fine. And we need a res.write head. And we want to return the response dot status code in that header, res.end. You might be wondering that what's all this that we are writing. Again, don't let that bother you too much. These are things that you can actually take out time to learn for yourself, but we'll just guide you along the way and provide the resources that you will need to actually learn them. Like someone asked earlier during the class, when we started the class, what resources they would need in order to learn all of this that we are teaching in this class. So, and I did mention that by the end of this week, we'll have compiled some list of resources for you to go back to, so that you can actually learn all of these things that we are doing in this class. Incoming message. it's going to be a promise, any for now. So we're returning new promise. This should be a request, not a reg. Request dot on. All right. So it's returning a chunk of data back. To string, yeah. And then when the request is ending, this is what should be sent back. All right, I think this is fine. Okay, Copilot is making our work faster. Yes, this is what I want. If there is a body, pass a body, but if not, send back empty, and that's fine. Resolve, pass body. If there is an error, yes, reject and send a response back, that's fine. And then when there's a request error, on error, you send a reject. All right, that's fine. And then the last function we have here, which will actually allow us be able to fetch all codes. Okay, Copilot is helping us to be faster here. So file handler, remember we wrote a file handler in our other file, so we want to use that to read the quotes. So let's import file handler at the top. So we have import all as file handler from file handler. Yeah, that's fine. Let me correct this. This is promise. All right. So file handler dot read quotes. Remember we wrote a function to read all quotes, and we are saying send a response back. Status code 200, message codes retrieved successfully, and data code send response. Yeah, that's fine. That works. Yeah, that works. This is void. Sorry, I'll need to reduce the font size so that I can see the full code. I'm going to restore that. So we have Okay, I need to close this guy. All right. Okay, that's fine. Okay. So we have our undo get all codes, and we have about less than 5 minutes to the end of the class. So I'm trying to see as much as possible we can cover before the class comes to an end, and also create time to actually share the remaining part of the source code. All right, so let's actually write a part that handles the request. So we have a part that handles, that passes response, that sends response. We have a function to get all codes. Then we need a function that actually handles the request from the client. Okay, let's rely on Copilot, since it actually has been helping us thus far. And to get all codes, else if. Okay, this works. I think for now we'll just stick with this. We don't need the other aspect for now. So this should serve us. But we want to be able to set some headers first. We need to undo base URL first and wrap all of this in a try catch so that in case it fails, anyway, so because of the time, I think what would benefit us more now is to actually see some of these things at work. Again, the code will be provided for you, and I think I should actually share the code, the link to the code, so that before the class ends, you see them and you'll be able to download them for yourself. All right. So what I intended to do for this class was actually have an endpoint that will retrieve just the codes. But before this class, I had gone ahead to write. Well, thankfully I did that. At least you'll be able to see all that we were meant to do in this class. But yeah, writing code is not that easy. And it's not something you just snap your finger and everything shows. So you go ahead, copy this code, copy this link. All that you have will be presented there. And like I mentioned during the beginning of the class, that there are two code bases that we've gone ahead to write for you. One is a console app that just calculates your date of birth. That's simple enough. And this other one that we were meant to cover in this class also is contained there. And yeah, you should be able to see all the functions that you are needed, that is needed for all of this that I was showing you earlier. Also, I think this might also help you. I've gone ahead to also host the API. So I hosted it on Render. Render allows you to actually host stuff. So I wrote the code and hosted it there. So you should be able to interact with it. Once you have your upscotch, you should be able to interact with it. So what I will also go ahead to do is the file in this code, the files here. I believe you can see my screen. I hope you can. The files in this link, I will also include this link as well there so that you can see all of it. All right. So I think that's the much we can cover in this class. In the next class, we'll try and continue from here. Again, the idea is for you to be able to get as much as possible, right? But if we are not even able to cover all, at least we'll provide you the resources for them. All right, so we'll see you in our next class on, yeah, that's tomorrow, right? But take note of these links, these two links. You can write them somewhere. All right, so thank you for joining the class. I know you have tons of questions, but in the next class you can ask them, and as much as we can, we'll try to attend to some of them. But going forward, I think what will best benefit us is to have pre-written code like we had today, because the time is too short to actually write something concrete. I mean, 2 hours is too short to do that. So pay attention to these links that I have up. Most important is this. It contains all the codes that we were meant to write in this class, and then another practice code that you can play around with. All right, thank you once again, and do have a good night rest. And if you're joining elsewhere from around the world, do enjoy the rest of your day.